So we've seen that when you have a system of equations, there is often an ordered pair that solves both equations and is therefore a solution to the system. The question we're going to focus on next is, how do you find that? And there are a few different ways to get there. The first one we're going to look at is called substitution. So on your toolkit, these are the steps we're going to follow. And I think let's just get into it. So here's our first example. We've got these two equations. They're perfectly nice equations. Our goal is to find the ordered pair, the x and the y, that make both equations true at the same time. So referring to our steps, step one is to solve one of the equations for one of the variables. To solve means to get the variable by itself. So that means either have an equation that is x equals stuff or y equals stuff. As I look right now, we don't have that yet. So it's all about making the easiest choice. And in this case, the easiest choice is probably going to be to get this top x by itself. And the reason I say that is that there's no number in front, no coefficient, meaning we don't have to divide anything. I can just do a little bit of subtraction. So I'm going to come down here for that. A little subtraction to move this 8y to the other side. Let's look at how that goes. So 8y minus 8y is 0. All that's left over here is that x that's now by itself. And on the other side, we've got the negative 8y plus 3. I'm typically going to write my variable first. That's a personal preference thing. Okay, that's what step one means. You need to have one equation that is one variable equals stuff with that variable isolated. Step two, once you've done that, substitute into the other equation so you can get a number for our first variable. Here's what that means. What I'm saying is x is the same thing as negative 8y plus 3. That's what an equal sign means. These are two different names, excuse me, for the same number. Just like you probably go by different names. Like I can go by Mr. Schrock. Maybe that's this version, but people also call me Matt. That's my first name, referring to the same thing. Two different ways of referring to the same number. So when we now go to this other equation, and by other I mean the second one down here, what we're going to do is, where I see the letter x, I'm going to replace it with its equivalent other name, its equivalent expression. X is the same thing as negative 8y plus 3. So 7x becomes 7 times negative 8y plus 3 in parentheses. The rest of the equation, leave it the same. Minus 6y equals 21. Now here's why we did that. Now we have an equation with only y's. This is an equation you can solve and get a number for the y. So let's do that here together. First, some simplifying. We want to get the 7 distributed so we don't have those parentheses anymore. So 7 times negative 8y, that's negative 56y. 7 times positive 3 is plus 21. The minus 6y is still there. And the 21 is still there. Next, I got a negative 56y here and a negative 6y. They're on the same side of the equal sign, so just put them together as they look. Negative 56 minus 6, that's negative 62 y's altogether, plus 21 equals 21. I now want to get this y by itself. So first, let's do a minus 21 on both sides of the equal sign. And then a division by the negative 62. We then have y equals 0 divided by any number is 0. So y is the number 0. So for our solution for this system, out of all the possible ordered pairs it could be, we've already narrowed it down. We know that the y coordinate has to be 0. Our final task: substitute that number that we just found once more to solve and figure out what x needs to be, the second variable. Here's how that works. We now know what number y is. You can go to this equation, or this equation, or the one we're going to use, this equation, put the 0 in where the y is, and figure out what the x needs to be. The reason I'm choosing this bottom one is that if I use the equation where x is already by itself, it's just a little easier than if I would use one of these other two. So coming up here to the top, I've got x equals -8 times y, and I think my y is the number 0. It's 3. So x equals -8y plus 3. X equals -8y, which we know is 0, plus 3. Then simplify. -8 times 0 is 0. 0 plus 3 is just 3. Now, when you're writing your solution, write it as an ordered pair. The x number first and the y number second. Lastly, you know how to check this. We're just looking to see if this ordered pair makes both equations true. Now, we're going to do a mental check here just to save some time, but feel free to write your checks out. 3 plus 8 times 0 would be 3 plus 0, which is 3. That works. Down here, 7 times 3 is 21, minus 6 times 0, which is 0, and 21 minus 0 is 21. That works too. So our solution is good. Let's go again. So step 1, solve one of the equations for one of the variables. So let's find the easiest option. Okay, there's no variable by itself already. Sometimes there is. There's no variable with a coefficient of 1, meaning all of these variables have numbers in front of them. Okay, so now it becomes a choice of what's easiest. We're going to have to divide. And the reason I know that is that there are numbers in front of all these variables. So if I solve for this top x, I'm going to have to divide by 3 at some point. If I solve for this bottom y, I'm going to have to divide by -2 at some point. So you just want to see what would give you the easiest division. For example, if I divide this bottom equation by -2, well, 6 is even, so that would divide nicely. 4 is even, so that would divide nicely. So it's a little work, but it's going to be nice in the sense that there will be no fractions or decimals. If instead I chose to solve for this bottom x, I'd end up dividing by 6. And 2 does not divide evenly by 6. I would have a fraction or a decimal left. That's not bad. It just makes the work a little tougher. So in terms of what's easy to solve for, in this case, you have choices. On the top equation, everything's divisible by 3, so you could solve for the x or the y. On the bottom equation, everything's divisible by 2, so you could solve for the bottom y. Let's see, I'm just going to pick this top y. So that's the one I'm going to choose to solve for. So coming down here, my goal is to get this y by itself. To make that happen, I need to first move the x term over. So 3y equals -3x minus 18. And then next, divide by that 3, the coefficient of the y. Now, here's how the division works on this side. When you have a sum or a difference, when you have multiple terms divided by a number, I want you to think of it this way. It's the first part divided by the 3, and then also the second part divided by the 3. The 3 divides into all the parts you have over there. Let's reduce. So 3 divided by 3 is just -1. 18 divided by 3 is 6. Step 1 is done. One of the equations is solved for one of the variables. I've got this y by itself. We are now ready for step 2. I used the top equation to get to here. So for the next step, I have to use now this bottom equation. Always got to be the other one. Where I see the letter y, I'm going to replace it with its equivalent expression. So 6x minus 2 times y, but y I'm replacing with, in parentheses, a negative x minus 6. The equals 4 stays and equals 4. Here is where I'd like you to do a little pause, solve this equation for the x, get a number, and then unpause when you're ready to check things. So let's distribute. I'll have 6x. Distribute negative 2 times negative x, it'd be plus 2x. Negative 2 times negative 6 plus 12. These are x's on the same side of the equation, so just add them up like they look. Now solve for this x. And then we'll do a division to finish off. So we think in our solution, x is negative 1. Be a little bit impressed. Out of all the infinite possible x values, we figured out which one it is without really that much work. Third step, once you've got one number, go back to your earlier equation. We're going to now put this number in where the x is, see what number y needs to be. So y equals the opposite of x. I think x is negative 1, because right here it says x is negative 1. So y equals opposite of x minus 6. Y equals opposite of x minus 6. Now the opposite of a negative is just a positive, and then 1 minus 6 is negative 5. So my solution, x number first, y number second, I think is negative 1, negative 5. Let's do that quick mental check again. So 3 times negative 1 is negative 3. 3 times negative 5 is negative 15. Negative 3 plus negative 15 is negative 18. That works. 6 times negative 1 is negative 6. 2 times negative 5 is negative 10. Negative 6 minus negative 10 is negative 6 plus 10, which is 4. Sure enough, it checks out. Okay, next up. This is a situation where students sometimes get confused because the first step is already done for you. Remember that first goal is to get one of the variables isolated? That's already done. I got a y by itself. You even have choices. I got y by itself more than once. So first step is finished. I'm going to take this, and where I see a y in the second equation, I'm going to put the x minus 1 in there instead. So x minus 1 equals 4x minus 10. When your x's are separate, your primary goal is to get all your x's in one spot. So I'm going to do a subtraction of an x, and let's see where we end up then. 4x minus 1x is going to be 3x's. Okay. To get x by itself then, let's add the 10. Now 9 equals 3x, and divide by 3. So we think that x needs to be the number 3. To finish, once you've got your first variable, when you got a number for that x, go to one of these equations. Put that number in for the x, see what the y ends up being. Just going to use the top equation. I think x is the number 3. So x minus 1 is just 3 minus 1, which is 2. So for the solution, list the x number first always, the y number second always, and let's now check it, make sure it works. 3 minus 1 is 2. That works out. 4 times 3 is 12. 12 minus 10 is also 2. Checks out. So there's the process. There's a recording of the odd-numbered practice problems with some more examples. I want to wrap up here with this chart. On that first step, how do you know which variable is the easiest one to use? Ask yourself these questions. Is there a variable that's by itself already? If there is, use that one. Don't work too hard. If there's not, check and see. Is there an x or a y that doesn't have a number in front of it? If so, use that. Get that variable by itself. If not, that's when you have to decide what's going to be the easiest choice. So by easiest, I mean, is there a variable that has a coefficient that divides evenly into all the other numbers in that equation? Like the 3 that we used in our second example. If so, use that one. If that's not the case, then it doesn't matter which one you pick because you're going to end up with fractions or decimals in any case. So here's the deal. As you're going through, the more practice you do, the better you're going to get. And thank you for sticking with it.